the fact that all that worked the first time is great. Okay, now I'll look for other questions. I feel like I want to include that in the main talk, so now I will look for other questions. Would it be better, rather than implicit constructors, to err on instantiating a type and less return from ordained methods? Well, so the thing about that is fine if you're like D or whatever, and you feel like objects should be allocated off the heap all the time. Then you can call something that returns you something. But often if you want to have fast code, you just want an instance of something on the stack, right? Maybe with a different syntactical way of doing things, that might be a natural thing to express. I don't know. If there were a natural way to do it, then maybe that's better than constructors, right? If you could error if people got something in an invalid way. So that, yeah, I mean, if we come up with something like that that seems strictly better, then I'm all for it. How do multiple return values tie in with the concept of constructors, destructors? Well, constructor and destructor invocation just ignore return values. So you could have a procedure that returns things and the return values just go nowhere. Any reason for against allowing multiple constructor in the struct for overloading, so it's visual while viewing the struct? Well, you could only have one constructor in the first place, and the compiler only calls it with a pointer to the thing. So, like overload resolution, the point of that overload resolution that I showed was not that those other things were also constructors. They weren't. They were just other procedures with the same name, right? It doesn't make sense to declare more than one constructor for a thing, because only one can ever happen. And it's an error, actually. You'll get the same like ambiguous procedure call type of error that you would get if you called overloaded procedures with arguments that would be valid for both calls, right? It says, hey, I can't disambiguate this. Is there a way to prevent the destructor from running? Seems like it always runs at the end of scope, even if you manually free. Yes. I mean, by yes, I mean, yes, it always runs. I've toyed around with the idea of being able to say, like, put a no destructor directive on a declaration. I've toyed around with the idea of that if you explicitly uninitialize it, then you should explicitly destruct it, and then maybe you can do that just with defer at the construction site anyway, so you don't forget. I'm not sure which one of those solutions is better, which is why I haven't done either of them yet, but either one of those ways of doing it would be pretty straightforward and simple extension of what's here. Does the built-in dynamic array have a destructor that frees the memory allocated dynamically? Yes. The thing for which constructors and destructors are most useful in C++ are smart pointers. Can they be done in your language? I do not like smart pointers. In fact, I very, very strongly, mega strongly dislike smart pointers. I don't think they're a good thing, so I don't think about them very much, honestly. I don't use them when I program ever. But, you know, I've demoed operator overloading, and all smart pointers are is, you know, a templated type with operator overloading, and we have all those facilities. So I presume that you could make a smart pointer with the functionality that's already here, but I haven't done it. If you can subvert auto invocation of constructors, then the argument that constructors help with forward compatibility doesn't really hold. No, I disagree. Look, the goal isn't to prevent people from like if people go out of their way to do something weird, then they did something weird, right? That's fine. What the goal of this is to make sure that the straightforward thing that you write, when you're trying to write code that's correct and does the obvious thing, remains correct in the obvious thing later. That's all I'm trying to do. If you're going to avoid calling the constructor for some reason, then you probably have a good reason to do that. And as soon as you step into that territory, then you're taking it upon yourself to maintain that. Like, okay, maybe you're making assumptions that are going to break when that API changes in the future. But you know as soon as you do something weird that you're stepping into that territory, right? So this is not a training wheels language where we prevent you from ever doing something wrong. But we want to prevent stuff from just randomly breaking for no reason, if that makes sense. Oh, I forgot to talk about copy. Oh my God, okay. So right now, oh God, this is important. I may have to edit this onto the end of the other thing. So there's a whole thing about operator equals, and my choice right now is that operator equal does not call destructors, it does not call constructors, it does not do anything that it wouldn't do to a so-called plain old data struct. And the reason behind that is that I do not like the disgusting quagmire that happens in C++ as soon as you have constructors. Like, you know, I mean, the fact that operator equals does constructors is where you start having this need for, you know, move semantics and emplacing and all that stuff. And it's a large amount of complexity. And what I would rather do, and I'm not sure this is the right decision, but my decision so far is if you want that complexity, then you opt into it instead of trying to opt out, right? Which is to say that if you're going to make some big abstract container type and you want it to call constructors and destructors when you assign things into the middle of the container, then you call the constructor explicitly, right? Equals will not destruct the thing that you're assigning on the left because there are too many times when you're doing performance programming when you don't want that to happen. For example, you don't want to require that this slot in this hash table contains a valid thing. Because if you're trying to make fast code, that could be uninitialized memory, right? Or let's say a dynamic array that expands. That could be uninitialized memory. It probably is uninitialized memory, and you want it to be, right? So my approach so far is that rather than having all these weird different kinds of equals, there's one kind of equal. It doesn't interact with constructors, and if you want constructors to happen, then you do that explicitly. Now, of course, C++ people would disagree with this, and they would say, oh my God, that won't enable you to build large abstractions and blah, blah, blah. And I disagree. And I also say that that part of C++ is such a dismal failure that we have to try something else because it's crazy how bad it is. So I have opted for simplicity. And I meant to say that during the main demo and forgot. Mr. Fourth Dimension says, one of the things that becomes annoying with constructors in C++ is when one constructor has to call constructors for the members that have constructors, and it is especially troublesome when the order of those members constructors, I assume you mean that when the order matters. Is there a good way to handle that here? Well, again, my policy is that constructors are only for small things, right? I'm not going the C++ way of, you do all sorts of crazy stuff in your constructor. No, I don't think that's a good idea. So I think that if you end up in a situation like that where there's lots of constructors on sub things and the order matters, then maybe rethink that design because it got crazy. My hope is that naturally, because the language discourages complex constructors, that just won't happen. But we'll see. You know, like I said at the beginning, I don't even know if we're going to keep constructors. So yeah, we'll see. Does global constructors suffer from something similar to C++'s static initialization order fiasco? Yeah, I mentioned that at the end. It's exactly like C++, where they initialize in an arbitrary order. And so if that order needs to be a specific order, then you're screwed. And again, I'm saying that's fine because you shouldn't have complicated constructors anyway. Constructors in this language are not the same thing as C++ constructors, right? We don't believe in resource acquisition as initialization. That's garbage. So on, right? That said, again, I did mention at the end of the demo that we may provide a facility for overriding when that happens, right? So you could say, don't call the global constructors, I will call them later, and I'm going to do something that needs to happen first, and whatever that thing that needs to happen first, you can make happen. You could probably do metadata introspection on that procedure and reorder the procedure if you wanted to make sure things construct in certain orders. Or, I mean, I didn't want to go, like one obvious solution to that is just put a numeric priority on everything global that says what order it should construct in. But honestly, I do not believe that you should be using constructors that complex. If you want to do anything complex, use a regular function call at a known time at runtime. I'm actively trying to discourage heavily non-trivial constructors. I'm getting some light in here. Can you please explain what your issue with C++ Destructor is? I can't, my issues are so many that, dude, I can't even start. Just forget about it. I'm not gonna get into it here. If you like C++, great. I don't like C++. So. Yeah, name guy is saying uninitialized means no auto-destruct. Seems like a completely reasonable and elegant way to prevent destruction. Yeah, that may be the right answer. The only reason I haven't done it is because I don't know yet. And I only have 2 destructors in the whole Sokoban game, I think. So I don't exactly have a large base of examples from which to make decisions yet. This reminds me, at the beginning I said there's probably a bug in string buffer, so I have to go look at that. Do I really not use smart pointers? Yes, I really do not use smart pointers. I really, really, really strongly dislike them. I don't understand. In fact, when they were first introduced, it was like Invasion of the Body Snatchers or something. Everybody thought they were great, and I didn't understand what the hell people were smoking. Do I ever use a reference counted value? Almost never. I don't find reference counting to be that useful. I do use it in rare cases, like maybe once in an entire game I will use something reference counted, but then I do that explicitly. I don't try to do it magically through a smart pointer. Because it'll generally be a bigger thing. It'll be like, you know, here's some large data. I can't give the exact example I'm thinking of without spoiling an unannounced game, but here's some large non-trivial amount of data. And we don't want to casually take references on it as we pass it around. It's like, you know, when somebody grabs a handle to it and when they release it. So yeah, I don't understand what the hell people's problem is that they need smart pointers, honestly. Can you change the order in which constructors, destructors, or struct members run? No, because again, I claim that if that matters, you're doing something wrong. Use a regular function. And again, that claim of mine may turn out to be wrong in time, but we'll see. You know, we just have to see what code actually looks like. How do you prevent double free if you're just doing simple mem copies for assignment? Well, so first of all, you're thinking about a case where, you know, somebody has memory allocated off the heap and they free that in the destructor, which I guess in certain areas that's a common thing to do, but it's a very slow thing to do. So I recommend not to do that very often if you don't have to. So I wouldn't necessarily think, in C++, you might think of that as the default thing that your constructor is doing. And here I don't necessarily, because, you know, we have other stuff like temporary storage that I demoed and so on. That's preferable to using the heap if it's applicable, right? So first of all, that's not the primary use case, I guess I'm saying. And then secondly, how do you prevent double free? Well, call something on the other guy that says, hey, we took the memory away from you. You know, set your pointer to null so that when you destruct, it's clean, right? Yeah. Now again, you can start saying, well, if people have to do something explicit there, then your whole forward compatibility argument doesn't work in that case because people won't have done that. And it's like, yes, that's true. But you can only, once you start trying to handle every case, you start getting into ridiculous C++ complication territory. And again, I'm trying not to do that. So yeah, we'll see how it works out. I mean, I'm trying to find the very fine line trade-off of complexity versus robustness, and we'll see. We'll see how this exact combination goes. So it says C++ class members are initialized in the order they show up in the class. That's true here also. So when I said, can you control the order? When I said you can't control the order, I meant you can't change it from the default order, which is the order they show up in the class, in the struct. Do constructors, destructors have to return void? No. Is the return value ignored? Yes. You might already know this, but I don't think you're recording it. No, I often don't record in OBS. Sometimes I do, but sometimes I just have it be on YouTube, and that's fine. What's wrong with the simple thing equals make thing? What's wrong with that is that make thing can't make something on your stack. It can make something on its own stack, which then goes away, right? It can make something in temporary storage, which it can return to you, and that's fine, but you want things on the stack. For maximum speed, you want things on the stack when they can be on the stack. And so there's not really a way to do that. However, right, maybe, so we were sort of saying this before, but maybe the right answer is actually to do something like that, where you say thing : equals make thing, and say, by the way, pass the stack argument, right? That would be fine. That would get rid of most of this constructor and destructor complication. It would also, however, get rid of the forward compatibility thing that I mentioned before. So there's trade-offs. But again, like, you know, having constructors and destructors is an experiment. What you mentioned and what somebody else mentioned earlier might be a different way to do the experiment. And I'm not sure which one is better. So we're just going to see. Am I against all use of RAII? I can see this being used for stuff like lock guard for critical sections. I used to have defer, but that's more typing. I mean, I do that sometimes. So I have a small number of cases where I do something like that in C++. So I'll have like a scoped mutex, right, where I declare it, and that just means, okay, grab this mutex when you hit this declaration and release it at the end of the scope. Like that, I don't necessarily have anything against that kind of usage. When I say I don't like RAII, what I mean is that I don't like the dogma that that's a good way to do everything, or that you must do everything that way, which unfortunately for C++, they've decided that you have to because you have to be exception safe, right? Which is crazy, crazy. Like everybody should have laughed them out of the room when they said you have to write all your code exception safe. So yeah, you can do that here, and I do that in C++. In fact, let me find somewhere that does it, right? Yeah, so here's a scope block where I grab a mutex and it'll release at the end of the scope. So, you know, I do that. Someone is saying the issue I have with constructor and destructor is that they obscure the flow of your program. You said you're actively discouraging people from writing complex constructor, but it's not a hard and fast rule. People will misuse it. Maybe, yeah. Like I said, I'm not 100% convinced that this is the right decision, but I'm trying it out. That said, people can make arbitrarily complex and nasty code anyway, so you can't ever stop them from that. But yet there is such a thing as the grain of the language encouraging or discouraging certain levels of complexity. And so what I'm hoping is that these can be a feature that live in the background and are rarely used. If that ends up not being true, then we may actively explore alternatives. I frankly don't like the amount of complexity that this adds to the language, but it's not clear to me that there's a better way to do it. And so, yeah, and again, there might be, but unless I figure out what it is or someone tells me what it is, then you kind of have to do the best thing that you have available, right? Oh yeah, Wizard OS March. So the question I asked before you wanted to hold off on, would it make any sense as an option, either additionally or in place of constructors, having attributes on data members to indicate they have to be set before using the object as a way to ease updating libraries? So maybe. The problem with that is that making sure that that happens is equivalent to solving the halting problem, which is unsolvable, right? So there will be cases where the compiler can't tell that you set that member if it happens in some function that's getting called in a certain way and blah, 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 right? Now you might say, well, that's fine. You have to do it in an obvious way that the compiler can definitely see what's going on. Then the language semantics have to guarantee that certain things work, for sure. Like you have to know that the program you're writing is correct. So it gets complex, and it's not clear to me what the right answer is. But if that ends up being the right answer, like if there's something like that that enables us to just get rid of constructors, I would be happy to get rid of constructors. Is there a way to force handling of errors that occur in constructors? I don't know what the answer to that would be. Because I don't know, first of all, how you know that an error happens unless you look at the state of the object, which you could do, but then you're in highly, object-specific logic, and then you're just doing whatever you're doing, right? There ain't no exception handling in this language of that kind. There's only panic handling. So there's not going to be like the constructor throws an exception. If you, my advice is to do things that don't fail. Like setting that pointer to the address of the buffer in the string buffer doesn't fail. So it's a perfectly good thing to do. But if you are going to do things that might fail, then it's just regular code. It's just like somebody called an init function, right? I suppose in that case they can look at the return value, and in this case they can't. So maybe there needs to be a way to look at the return value. But again, I feel like if you're going to do that, you should just call a function. I don't know. Would it be possible for Constructor to live in a DLL that the user doesn't have the code for in their current module? Yes. As custom allocators are heavily used in your code, I guess there is no such thing as a strict aliasing rule. I have not decided what my aliasing story is. I don't like the C++ rules about aliasing, but I haven't thought about what might be better. Now, of course, you want something because it matters a lot to the performance of your program whether the compiler knows whether things are aliased or not. But I'm not sure what that's going to end up being. It remains to be seen. Will I include any kind of error handling? Return value handling is error handling. Apart from that, there will be panic handling. Apart from that, no. You can return things on the stack if you remove less from the stack when exiting the function than was allocated when this function was called. Yeah, but that's a little bit bananas. You could do that. Like it puts constraints on where things have to be, but those are livable. And you need a weird syntax. You would have to introduce some weird syntax that says this thing leaves a certain amount of memory on the stack. Which, again, you could do. I just haven't followed that train of thought to its logical conclusion to know if it's appealing relative to this. But yeah, you could do that for sure. Yeah, the triple dash works inside structs as well. Do I think I could do a stream where I analyze RAII gone horribly wrong? I don't know, man. I mean, I'd rather just give good examples of fast code, which is usually not going to be RAII because RAII is anti-fast software. I don't know. I mean, I've given as much of an explanation as I really want to give about that. It's like, it's really something that you either get from experience or you don't. Like, explaining it is hard. Do I use standard thread? No. No. I do not use std : anything except in one side project where I used std function because it was a lot easier than, like when you use lambdas, you kind of have to use that or roll your own, and I didn't want to get into rolling my own. But I don't like the C++ standard library. I think it's junk. Is it possible that forward compatibility isn't worth the trouble? Why not have the user be required to be conscious of the versions of libraries they're using? Yeah, that's one thing we might do. Yeah, who knows? Wouldn't the simpler thing be for library writers to maybe add a remind callers of my new explicit init flag, and the compiler would warn callers of all areas they need to check? Yes, it's annoying, but far from hidden breakage in your forward compat scenario. You could do that, but then people need a way to explicitly signal that they paid attention to that and turn the warning off. But yeah, I mean, that's one way to do it. And it's a little more annoying because you're not like assured that your code is right. There's still some manual steps that you have to do when you upgrade a library or whatever. But possibly. But we would need to think about that. How does that exactly work for real? I don't know exactly. Do we have returning structs by value? Yes. Then x equals make x would work on the stack, wouldn't it? I guess, sort of, but you're relying on an optimization. You're relying on an optimization that, that we provide the L value of the final struct to the function, which we actually do. But that, I mean, yeah, come to think of it, that mostly works. Really, the question is just about internal to the procedure. Like right now, we don't necessarily. I haven't looked at how well that optimizes when you're actually, because this struct is going to have many values, and those are all going to get placed into that spot. I don't know, man. I mean, maybe that would work. Again, the forward compatibility argument doesn't happen there. But that might be a solution. Yeah, I don't always think of everything. Someone says, I think if you integrate constructors as a tagged function, it reduces the overhead of the concept, similar to how you can tag procedures. What do you mean? I don't understand what the tag does and how it helps. Can I speak a little about the perf improvements I made to the compiler? I mean, it would have been fun to do those on stream so that people could see, but I did them working at cafes and stuff where it wasn't convenient to stream. It's just regular optimization. I didn't do anything too crazy. It's just I was running telemetry where if you guys saw me using telemetry before, I busted that out again and saw what was taking time and attacked it. That's how optimization goes. Enemy Mouse is saying, I figure upgrading a lib shouldn't be done lightly while writing code without worrying about the possibility of magic here and there is a higher priority. That might be true. That, I mean, let's just see. If constructors turn out to be a bad idea, I have no qualms with ripping them out of the language before we go to 1.0. If there's a better thing to do. So, yeah, I mean, what I would like to do is just, we can see them in the language, we can see how they are, and we can try alternative approaches. And if the alternatives end up looking good, then get rid of constructors would be awesome. Because I do dislike the magic. Now we're in a procedure somewhere when we didn't necessarily expect it. I I don't like that, and the pre and post main is a little bit ugly, right? Like, oh, some code is running in an arbitrary order pre-main, right? So, yeah. Am I gaming after this? I don't know. I'm kind of tired today. I might just go home. I might just go home. Oh, okay. So as a follow-up to that tag question, I did this for console commands on a demo where I tagged functions to make the boilerplate safety check and calling. Yes. So, but what would that mean? How are you suggesting? Do you mean that there's a safety check that would happen, or what? I'm not sure what the tag would indicate in this case. Is there anything in the language that can enforce a function's purity? Right now, you can do that through a compile time metaprogram, right? You can inspect a function and make sure that it has no references to external things, except of course, if it calls another function, you can recursively check that one and so on. However, I do think that's important enough that there should be some more built-in things that help you with that, but I regard those as relatively smaller features that'll happen later. We've got some bigger features in the near term. We just mean that constructors work through the same system. For something as basic as constructors, like I guess you're saying that the compile time metaprogram would alter the code to insert the call to the constructor if it's tagged. You could do that, but that's a pretty invasive thing to do. Oh, but you mean maybe the library writer does that to make sure that you don't forget. Like if yeah, maybe. I mean, I don't, so in a way I don't like that because that's even more stealthy than this, right? Like if your library is going to go insert a bunch of procedure calls invisibly into your code, that's not so great. Like at least if there's a constructor, you kind of can know that that constructor gets called. Even like your IDE could draw constructor gets called here, right? In fact, I don't know why C++ doesn't, Visual C++ doesn't do that, for example. It should. That said, some variant of that idea might work out. Yeah, maybe. The scroll bars do not have explosions yet, sadly. Yeah, so it's interesting. So generally about this idea of returning something that's on the stack or so I've been thinking for a while that the semantics of declaring something on the stack is a little bit weird. Like, why is it that way? It's sort of just inherited from C or from other languages, and like, it feels weird to do now, to declare something on the stack. And I don't know where I'm going with that, but like maybe that dovetails into some of these other issues, that if these things were expressed in a different way, maybe it would be, maybe something would work out naturally that is not obvious to me right now. With the metaprogramming facilities, is it possible for the library writer to make a compile time check to see if the user called whatever newly required initializer was called? Yes, you could do that. Again, though, I mean, really determining that is equivalent to solving the halting problem, which you can't do, right? So what you could do is things that are easy to discern statically, like if they called the thing on the very next line or in the same basic block without any branching around it, right? Or whatever, stuff like that, you could tell pretty easily. But that does restrict, if you're going to error if you don't see that, then that does restrict the freedom of the programmer. But maybe that's fine. I mean, maybe there isn't maybe if you just decide to do that, there isn't so much a forward compatibility problem and we don't need constructors, maybe. The thing is that I haven't totally worked out a system of how do we organize it that libraries do metaprogram stuff, right? When your main program does metaprogram stuff, it's very easy for you to control that and make it happen, right? Then do you explicitly call out to the libraries metaprogram stuff within yours? If that's the case, you might forget to do that, but then maybe the library can assert if something didn't happen, right? Like maybe that adds a value to your program and the library detects that you did that and compile time asserts if you didn't. I don't know. So there's a whole like convention there that hasn't been established. So maybe, again, maybe that would be a good alternative to constructors, for sure. I don't know. It depends on, you know, the good thing about constructors is they're very convenient to use. The bad thing is the invisible magic, right? So I've tried to minimize the invisible magic, but there is still a little bit. And yeah, I mean, we just have to decide what's the trade-off there. Has that megaton idea come to fruition, asks Dr. 2X or Dr. Twox. It has not yet. However, we're very close to being able to try it. The polymorphism cleanup that I did previously, that I streamed, was related to getting polymorphism ready so that I could build new features on top of it. And the megaton idea is one of those features. But I'm probably going to start with a slightly simpler one first. Why not make invoking the constructor extremely explicit, e.g. in Java you have equals new foo? Because, well, because by default that puts things on the heap, right? You could say equals stack foo or whatever. Maybe, but then again, the forward compatibility argument, like, if that constructor didn't exist and then now it exists later, blah, blah, blah. I don't want to get into circular things. Like, all the things that we've said so far in this discussion apply. Oh yeah, you could say aloka instead of new. Yeah, it's true. Can I tour my office? I don't know. It's hard to see things because it's dark. I don't know. Camera probably pointed down and you couldn't see anything anyway. Where are we looking at now? Would defining constructors be simpler if you just overloaded a global proc with a special name to take a pointer to your new struct and initialize it? I thought about that. So, you could say that construct is kind of not exactly a reserved word, but would get called with the pointer to your thing. Um, the problem is that that's pretty restrictive. Um, like you can't, like some of the cool stuff that we did about reusing polymorphic procedures um, would would be hard to organize in that kind of a case. And I also just didn't like the idea of taking part of the namespace. Can the library user maybe set a variable as part of the import statement saying which API version they're using? Well, for sure. Like, we haven't gotten to the super formalization of library stuff yet, but when that happens, then yes, when you import a library, you'll say what version explicitly. You don't want things to magically break if somebody upgrades a library. That's no good. What would a modern version of BASIC look like? I don't know, man. What was that one thing in the demo that you said you were lazy and didn't do, but nobody cared, so they wouldn't remember to ask about it in Q&A? I don't know if it's cheating to ask this, because I was thinking that somebody would ask about that feature by name. But the thing was, if you remember, you can tag procedures as symmetric, right? So that, for example, if you use them as operator overload for plus, that the arguments will swap if they type check in the other order. That should work with constructors, and I got lazy and didn't do it, right? But if we keep constructors, that'll work eventually. Am I still thinking about doing a namespacing feature? Yes. All right. About the scripts within the program, of course, you will be able to do that in some way, but not by interpreting them. Not by interpreting them with a heavy runtime. It would happen by like you include the library, or you include the compiler as a library, and then you use that library, right? So it won't be, interpretation of the language won't be built into the runtime because that's a bad idea. But yeah. So that, I think that's all the questions.